in your conclusion, this is where you now need to tie it all together. So we need to go back to our investigation question and tie that in. We need to do the analysis and tie that together, summarise that, and so on. So there are the components that we need in our conclusion. We need to be able to make the call. And this is looking at how much overlap there is, and have I got enough evidence? Are the medians far enough apart for me to have enough evidence to say that they're different? I need to answer my investigation question. I need to make an inference, and I'll talk more about that in a bit. And we need to discuss what sampling variability is. Okay, so let's start with making the call. So this is a piece of information straight from the curriculum document, and what it talks about is if I've got two graphs of A and B, and if there is no overlap of the boxes at all, and you can see here I've just put this red box there. I'll just go back and show you. See, when I look at that, those two boxes have no overlap at all. There's space between the two boxes. So if you've got that case, absolutely you can make the call that Group B tends to be bigger than Group A back in our population. So that's what we can definitely do if there's space between them. But what happens when they're a bit closer together? So this is when we're looking at the median, and we're saying if the median of one of the samples, and I've just drawn on there the median for A, if the median of that lies outside the box of the other sample. So now I'm going to draw a red box around Group B, and you can see here that the median for A doesn't cut through that box, so it means it lies outside of that box. Then I can make the call for that, and I can say that B tends to be bigger than A back in our population. So let's have a look at this example here. So we've got our bag weights of our males and females. First thing I'm going to do is find the median of one of the groups and see, does it lie inside the box of the other group? So here is the median of the female group that I've put on, and now here is the box of the male. Does that median lie inside or outside the box? And I would say that it lies inside because it cuts through the box. Okay, so that lies inside. Now let's double check with the other median. So that was using the median of the female. Now let's do the same thing for the other median. So here's my median of the males, and there's the box of the females. Does that lie inside or outside the box? And in this case it also lies inside the box. So what it means is that if either of them were outside the box, then we can make the call. But in our case, neither of them lies outside the box. They both lie inside each other's boxes, which means we cannot make the call. So I'm going to say that. I'm going to say I cannot make the call because my median of the male bag weight lies inside the box of the female, and the median of the females lies inside the box of the males. So here I'm giving the justification, which is our merit. The because is our merit. So we cannot make the call for this. So now I'm going to use that to answer my investigation question. So this is what the investigation question would have been. I wonder if male students tend to have heavier bags than females do for students at Census at School, NZ. So how do I answer this question? This is when I look and say, can I make the call? If I can make the call, I have enough evidence. If I can't make the call, I do not have enough evidence. It tells me the medians are too close together and they could be the same. So that's what I'm going to say, is in my sample I don't have enough evidence that the male students tend to have heavier school bags than females. And you notice I've used the similar very, very similar wording as the investigation question itself. I've just added on this bit at the start, which is saying I don't have enough evidence. Okay. Then I need to go on and make an inference. And now we've got to think, well, I was interested in the population, and I've got a sample of data, and I've found some results about my sample, and now I've got to say, well, what does that tell me about the population that I'm interested in? So because I've got a random sample, it means our data is going to be representative of all school students in New Zealand. So that means I can apply my conclusion to all of them. So my inference will be that boys do not tend to have heavier school bags than girls for all students in New Zealand. Because I don't have enough evidence, I can't make the call, so that means I'm going for my sample, and that also therefore is going to apply to the population of all students, and I'm going to say I infer that boys do not tend to have heavier school bags than girls, which is what I might originally have thought. And that is an inference. I'm making a suggestion about the population based on my sample. The last piece that we want to do is our sampling variability. And this is being able to say, well, what would happen if I took another sample? So we want to think about data. And if I've got another sample, so I've got one set of data, do another, if I had a different sample, would the data be exactly the same? And I don't think it would. If I was to measure a group of students in one class and find their heights, and then I was going to go to another class and measure another group of students, I'm measuring different students, so the heights of those students are all going to be different. So my data is going to be different. Now let's think about the summary statistics. So that's our median, our mean, our upper quartile, lower quartile, interquartile range, all of those. What would those summary statistics be? Would they be similar? Would they be different? And we know that they're not going to be exactly the same because the data is going to be slightly different because I'm measuring different kids. But the median height of a student in one class, if I think about where the middle height in that class was going to be, compared to the middle height in a second sample, those middle heights should be similar to each other, be round about the same, because they're both still part of the population that we're interested in. Okay, now remember our sample is representative of the population. So our summary statistics are going to be similar. What about the conclusion? Well, in my conclusions, remember our conclusion just before was that we don't have enough evidence to make the call. So that means we can't say that boys tend to have heavier bags than girls. If I take another sample, I would expect that conclusion to stay the same. Because yes, I've got a new group of students and I've got a new weights of their bags, but I expect that the first group was representative, and so my second group is also representative, so they should both tell me the same conclusion. Okay, so here's an example of how I'd write that out. If I took another sample of different girls and boys, then I'm going to get different measurements of how their weight of the school bags, because you've got sampling different kids. You've got measuring the weights of bags for different students. But with that sample, the median is likely to be similar. It's not likely to be exactly the same, but it is likely to be around about the same middle point value. Then with a different sample, and I'm going to expect that my conclusion is going to stay the same. And that conclusion I came to was that boys do not tend to have heavier school bags than girls for all students across New Zealand high schools. So I expect that conclusion to be the same. Different data, similar medians, but the same conclusion.